So, per our conversation, I am sending you this letter. As we discussed, at this point, I must stay anonymous. The fluid control industry is a small village. Let us just say I am a professional in the valve industry. The point of this letter is to draw attention to certain aspects of seals, valves, and actuators that must be part of any artificial environment to maintain life and functionality. I have no special knowledge of the ISS, but there are principles of fluid and motion control that cannot be ignored. We assume that the ISS has supply systems for water, fuel, air, etc. These systems would all require valves, pumps, and seals at a bare minimum. Without systems to deliver, send, expel, vent, filter, and store these fluids and gases, life on board would be impossible. Tubing, pumps, tanks, and valves would need to be present across all of the living areas to assure, at the least, fresh air. Seals, such as O-rings, would be required throughout the ISS to hold in gases and fluids. Valves would be required to meter these gases and fluids and to maintain proper pressures. Actuators would be required to move devices such as the Canadian arm, hatch openings, etc. Anything that is not moved manually requires an actuator. Let's look at some of the questions that pose a problem. Okay, so that was the end of his little preface. And then he goes into, the first thing he wants to address is seals. And here we go. For aerospace applications, the most commonly used seals and O-ring materials, and we're going to get into a couple technical things here, are GLT-type fluorocarbons, generically ASTM D1418 type 3 elastomers. I don't know that word very well, which have a glass transition temperature of negative 30 Celsius. Materials of this type that meet the new AMS 7287 and predecessor AMSR 83485 specs have a useful operating temperature down to negative 40 Fahrenheit and up to 400 degrees Fahrenheit. Even though this is an impressive temperature range, it appears that the ISS is being exposed to temperatures beyond this range. There are special Teflon-based seals available that can extend a little past this range, but they are not made with flexible or compressible materials. Therefore, the mating components would have to be manufactured within a millionth of an inch tolerance to prevent a seal from moving and thus leaking. Not convenient for a hatch or a fuel valve that is in constant use. Perhaps the seals are shielded from the temperature changes. Perhaps. But the outside of the ISS does not seem to show the insulation units required to accomplish this. Another problem with seals is that they wear out. Seals would have to be replaced frequently. Preventative maintenance of seals and sealing services would keep a maintenance team busy 24 hours a day. Seal replacement would require sealing off areas, cleaning and sealing surfaces, since in many cases a human hair can cause a seal to leak, lubrication, polishing sealing surfaces, or replacement of modules, etc. I do not think any of these things have been observed on the ISS. Seals also require back pressure to seal. I have no idea how a seal would function against a vacuum. We have no calculation for it. Any seal I have ever seen would simply be sucked out into space. How fuel, air, water, etc. are all contained and moved in the ISS, I have no idea. The seals of the ISS must be flawless, maintenance-free, immune to temperature changes, basically miracles of modern science. We in the industry would hold such mythical seals in awe and reverence if they existed. And that was the end of seals.
Just to kind of comment on one thing,
yeah.
I do actually have a little bit of exposure to that because on board our ships, and I can kind of confirm what he's talking about, for our evaporation system that we use to turn salt water into drinkable, potable water, we use an evaporator system. It's 6-stage evaporator. And it is actually working underneath the principles of a vacuum because anyone that knows anything about evap systems, you can actually boil water at a much lower temperature when it's in a vacuum.
Yeah.
Throughout stages. And they're constantly doing maintenance on that system. It's constantly going down. It's constantly putting us into limited water usage hours because of how much routine maintenance has to get done on it. And it's just one simple, it's big, but it's one device, on the ship that they
Sure.
constantly have to work on.
Sure.
Is that because you're cleaning out impurities all the time?
Yeah, everything. I mean, fluctuation between temperatures, salinity, impurities in the water that's coming in, seals wear down, they break down. Like he said, it really would take a 24/7 maintenance crew to constantly be getting in front of the astronauts all the time, blocking their screen time, because they constantly have to be transiting all throughout the ISS, fixing this stuff and checking on it.